This lecture is going to be a theory lecture where we're understanding all about methods. So let's go through some slides in here. What are methods? Methods, which are also called functions. We can use them somewhat interchangeably, those terms. There is a difference, but not anything we need to worry about at this point in time. Methods, also known as functions, execute blocks of code that make our game do things. To achieve this, we must, first of all, declare and define our method. We need to give it a name and say it exists, and then we need to say what it actually does. And then we also need to call our method when we want it to execute. So let me give you a somewhat silly real-world example here. Might be that you need to clean your room, which involves picking up the clothes, throwing out the garbage, and removing that moldy slice of pizza that threatens to mutate and destroy life as we know it. So that's what clean your room method involves. And the way that we call the method is, well, it's probably your mother getting there and saying, hey, go and clean your room. And we know what clean your room means because it's been defined. We might ignore it sometimes in the real world example, but we know what calling the method of clean your room actually means. It means go and do the steps that we've defined and agreed to. So here's the syntax used for declaring a method. We need to give it a name, and the name, the convention, is uppercase for the start of each word we have, and we try to name it so it makes sense. Clean your room is a much better method name than just clean, for example. Clean what? Clean how? What does that mean? So clean your room. We need to add parentheses afterwards. So when they're rounded like this, they're called parentheses. When they're square, they're called brackets. And when they kind of have that little curliness to it, they're called braces. So just in case you were curious, they each have different names. So we have these parentheses, and when there's nothing in it, it means that nothing else is required as a parameter. And I'll get into parameters in a moment, but a lot of methods don't have a parameter, and that's fine. A lot of methods don't have anything we're looking to return, so we need this keyword void that says nothing will be returned. What do we mean by return? Well, it means when we call the method, we're expecting to get something back. And I'll explain that in my real world method in a moment. I just wanted to show you the structure for this. We need a return. If there is none, it's void. We name it. We have the curly braces. Then within that, we have the things to do, the statements, and each statement needs to end with a semicolon. So as I mentioned, there's more flavor that can be added with our methods. There's two common things that we can consider. One is we can ask for some information to be returned, and that's the terminology, returned. And also we can specify some parameters which are needed when calling the method that says, hey, if you're going to call it, you need to provide these parameters. So let's use our real world example to understand returning and parameters. We're declaring the method, and at the time of declaring what does clean your room mean, we're saying we also need to provide a deadline so it's clear on how long we've got to clean the room, just in case you're sitting there, you're right in the middle of a game and it's really important and you're like, do I have to do it right now? And you need to know from whoever's asking you to clean your room, do I have at least half an hour? Can I do it after dinner? When do I have to clean my room? You're asking for that information to be provided when someone calls this method. And so we'll be using this deadline somehow within our clean your room method. And then we have the other things that we need to do in terms of picking up clothes and stuff and the moldy pizza, etc. And then in terms of returning, that we're going to tell the caller whether it is dirty or not. So we're going to provide back to the caller, hey, I've cleaned it, so the caller knows what's going on. And so I've just denoted in here, parameters are the white text on the green and the return data is the bluey text on the white. And so when we're calling the method, it's the same thing. Hey, go and clean your room. Okay, I'll tell you how long. You've got 1 hour, or you need to do it before dinner, or whatever it is that we're requiring in here. And at this point of calling, we're going to say what we need to return. When you've done it, can you tell me if the room is dirty or not? Can you tell me if it's clean? Or maybe in here you can have, can you tell me if the slime and the grime has actually been cleaned up properly? So it's interesting to know that there's some flow of information here. Sometimes it's just a case we've defined it and then we call it and that's it. Other times we're saying, well, we actually, when it's called, we need to pass information in, and that's in the form of parameters and arguments. Just to be clear, a parameter is the information we need, and the argument is the actual specific value of that. So it kind of means the same thing. People use these interchangeably, but one technically is the thing we want, and the other, which is parameter, and argument is the thing we're giving. And then also the information flows back the other way. So the method, after it's done its stuff, can tell the place where it was called, hey, here's some information that might be useful to you. So just to be clear, with this syntax we use for declaring a method, we need the return type at the start. In this case, it's a bool, which is going to be true or false for a particular thing. If there's no return type required, we need to put in the word void, so the method knows there's no return type. Then we have the name, and if we have any parameters that require, we need to say what type we're expecting. So int is going to be a what? It's going to be a whole number. So if the method tries to return 1.72, it's not going to be happy times, because it's like, I didn't want a float, I wanted an int. So we need to pass in this time when we actually call the method. And that's how we write it in here. We can have multiple parameters. We would write type and then name. So this is the name. We can call it whatever we want. We can call it time, or we can call it Bob. And then after defining each parameter, we would put a comma and then the next one, comma, the next one. Each time we would have type and name of the actual parameter. The other important part for this cycle is when we are requiring return information, we need to, somewhere within our method, usually at the end of it, we need to use the return keyword that says, here is me returning what it is you asked for. And we've got this bool. This is a variable we've created here. Is room dirty? And that's either going to be a true or a false based upon the other things that we've done and what's worked, etc. And then we will return back whatever is contained within is room dirty. So if is room dirty is currently true, then we would return true back to the place that called the method, and then wherever called the method can do what it needs to do with that information. Maybe if the room is still dirty, then it keeps calling clean your room, clean your room, clean your room, until which point it is finally not dirty and is room dirty returns false. And the syntax for calling a method is a little bit simpler. You just type the name of the method. And for this example, there's no arguments to be fed back in, so that's why it's empty between our parentheses, which is what a lot of our methods will look like in this project. But if we had any arguments we needed to pass in to satisfy the parameters, we would put them in there. Remember the semicolon on the end, we often miss that, and that's why things don't work. So that will execute the statements defined in the code block. What I mean by that is when we declare, we've got all these things in the code block. When we call the method, we just need to say, do it. Go do it, and it knows what is contained within that method. And so we've been looking at a couple of methods in the early part of this project, start and update. And what have we been doing there? We've been defining them or declaring them or calling them. What's actually going on? We've been defining them. We've been putting extra content, extra statements in there, but not actually calling them. So where are they called? How is that happening? Well, Unity's got a whole bunch of internal logic that's taking care of calling them for us at the right time. It's got an order of execution, and it will say for any game object that has a script on it, if there is a start, then when at the right time, when we click the play button, or when that particular game object comes to life or is active, depending upon the situation, then do whatever is in start. And these sorts of methods are called callbacks because Unity is taking care of calling them. They're already calling start and already calling update in its own special way, in its own special place. We just need to take care of putting in the information and defining what happens within them. So that's a lot of theory. It's a lot to take in. Hopefully it's useful for you. Some of it we don't need just yet. Some of it we won't need in this project, but I wanted to give you that grounding. So you're looking on forums or you're using AI to help you with code, at least you can understand what it is that's showing you when you see, oh, there's some words in these parentheses. What do they mean? Or there's a word before the method. What does that mean? You have a greater understanding of what's going on there. So hopefully that is useful. I'll see you in the next lecture.